All right, so in this video, we're going to start solving trig equations. So we're going to start by solving this algebraic equation here because much of solving trig equations is like solving algebraic equations. So you kind of do the way you solve algebra equation, the same steps that you use for that, you're going to start off using the same steps when you have a trig equation. It's just the end part's going to be a little different. We have some extra steps to do. So this is an algebraic equation right here. We got to solve for x. So if it's linear, you're going to do inverse operations. So what I like to use is something called SAD-MEP. It's just PEMDAS in reverse. It tells you when you have a variable that you're trying to isolate, like x, the order in which you do these. So first you would look to add and subtract something on both sides. All right, those could be done in any order. Then look to divide and multiply on both sides. All right, those could be done in any order as long as divide and multiply after add and subtract. Then if you add like a square root or an exponent, you do that stuff. And then anything inside parentheses or like inside a trig function, in this case, we're going to do last. All right, so first thing I'm going to do is I can add 5 to both sides. So I get 5x plus 12 is equal to 2x. All right, then I could subtract 3x on both sides. And I get 12 is equal to negative 3x. All right, so I added and subtracted on both sides first. Then I divide by negative 3, and I get x is equal to negative 4. All right, so if you could do that, which I'm sure most of you can, or all of you can, you're you're halfway there to solving a trig equation already. All right, so how do we apply that to something like number 1 here? Well, instead of solving for x first, we're going to solve for the sine of x. So instead of getting x alone, we're going to start off by getting the sine of x alone. So what I would do is I'd treat this like it's the equation, 2 times y minus 1 equals 0. And I have to solve for y. So if I was solving for y, what would I do? I would add 1 and then divide by 2. So I'm going to do the same thing here, but I'm going to solve for the sine of x. So the first thing I'm going to do is add 1 to both sides. So I get that. Then I'm going to divide by 2. And I get the sine of x is equal to 1/2. All right, so that's half the battle. Isolate the trig expression. So we got the sine of x alone. All right, now we have to figure out what values of x work here. So now we're going to use inverse operations, or sine inverse in this case. So when you're given a trig function to solve, you're going to be asked to do it, 3 different ways. One is to answer in degrees, so find all the answers between like 0 and 360, or to answer in radians, so find all the answers between 0 and 2 pi. So answer in degrees or radians, or you got to find all solutions. So I'll show you how to do that later, but it's one extra step, and it has to do with coterminal angles. So first, can anyone tell me, just by looking at it, what value of x would satisfy this trig equation here? The sine of what angle in degrees equals 1/2? Does anyone know? I know we're a little rusty, so I'll take this one. All right, 30 degrees. The sine of 30 is 1/2. Now, the way you could do that with a calculator would be to do the sine inverse. And the sine inverse of 1/2 is equal to 30 degrees. Now, remember, when you do sine inverse on a calculator, it's only going to give you the angle between 90 and negative 90. Same thing with tangent inverse. And if you're doing cosine inverse, it would give you the angle between 0 and 180. All right, so we got 30 degrees. So that's one of our answers here. X is equal to 30 degrees. All right, now there's usually going to be 2 answers when you're looking at all the angles between 0 and 360, because there's always 2 quadrants where a trig function is positive and 2 where a trig function is negative. So the other answer would be the 30-degree angle in quadrant 2, because sine is positive in quadrants 1 and 2, but negative in quadrants 3 and 4. That's what the T means. T means tangent's only positive in quadrant 3. C means cosine's only positive in quadrant 4. All right, so the angle in quadrant 5 that has a 30-degree reference angle would be 150. All right, so that's our other answer. Okay, so just to recap what we did, all right, you can't see the problem, but it's in your notes. Hopefully you have those open. We did 2 sine of x minus 1. we isolated the sine of x. We got the sine of x equals 1/2. Then we just did the inverse operation to see what value satisfied it. And we got 30. The sine of 30 is 1/2. Then we found any other angles that worked by looking at which quadrants is sine positive in, because it was a sine of positive 1/2. If it was a sine of negative 1/2, then we would look at quadrants 3 and 4, where sine is negative. All right, so that's how you would do it for all answers between 0 and 360. And if we were doing B, all answers between 0 and 2 pi, we would do it the same exact way, except we would answer in radians. So we could even do it in degrees first and convert to radians after by multiplying by pi over 180. All right, we get 3 pi over 18, which is pi over 6. So that would be one of our answers. All right, and then the other one would be convert 150 to radians by multiplying by pi over 180. Then we get 15 pi over 18, and that would be 5 pi over 6. Okay, so those are two answers there. Now to find all radian solutions. So remember, this right here would be pi over 6. All right, that angle, when you take the sine of it, you get 1/2. And if I were to take that angle and add 360 degrees to it, right, so add 2 pi, because that's 360 degrees, we would get a coterminal angle. All right, so that would be 2 pi plus pi over 6. That would be 13 pi over 6. So that would be another answer that works. Oops. All right, and you could keep adding 2 pi. You could just keep adding multiples of 2 pi and find coterminal angles. So when it asks you to find all radian solutions, you're gonna take your angle, pi over 6, and you can add any multiple of 2 pi. So the way we express that is 2 pi times k, where k is an integer. Remember, integers are numbers that are whole numbers, positive or negative. It's like 1, 2, 3, or -1, -2, -3. All right, so if we add a whole 2 pi, or 2 times 2 pi, or 3 times 2 pi, or 4 times 2 pi, as long as we add a multiple of 2 pi, we're going to end up in the same spot. Okay, so when it asks you to find all solutions, it's the same steps every time. You take one of your solutions and then add 2 pi k, as long as k is an integer. And then we have to do the same thing for our other answer that we had. All right, this one right here, which was 5 pi over 6. All right, this angle in green, because if you take 5 pi over 6 and add any multiple of 2 pi, so 2 pi is 360, you're going to end up in the same exact spot where the sine of that angle is 1/2. So the other answer would be 5 pi over 6 plus 2 pi k, where k is an integer. All right, so when it asks you to find all solutions, if it's in radians, add 2 pi k. If it's in degrees, add 360k. And just think all coterminal angles, they're going to have the same value when you take the sine of them, because they're the same angle. They just, like, when it's all said and done, it's in the same position, like 30 degrees and 30 degrees plus 360 is 390. They're in the same position. If you just keep adding 360, just think about it. If you stood where you are right now and turned 360 degrees, you would end up in the same spot where you started. All right, so now let's apply that to something a little more complicated. So let's see, why can't I see this on my screen? All right, so for number 2 now, all right, we're going to solve this equation. 2 times the cosine of t equals 6 times cosine of t minus 2 root 3. So you should think of this equation as something like 2 times x equals 6x minus 2 root 3. And think about it as you're solving for x. So we're trying to get x alone. So what would you do? Well, you could subtract 6x on both sides, and then divide, and we would get x alone. It works the same way, but instead of solving for x, we're going to solve for the cosine of t. All right, so we want to first always isolate the trig expression. So if I subtract 6 times the cosine of t, I get -4 times the cosine of t is equal to -2 root 3. So we're trying to isolate this part. right here, the cosine of t. So to do that, we're going to divide by -4 because we have -4 times the cosine of t. So now we have the cosine of t is equal to positive √3/2. Positive because it's a double negative, that cancels out. And then 2/4 becomes 1/2. So now we got to figure out what values of t between 0 and 2 pi satisfy that. So can anyone think of an angle that you could take the cosine of and get √3/2? Now, since it's a positive ratio, we know that it should be in quadrants 1 and 4, the two angles, because that's where cosine is positive. So at this point, you can either look at a unit circle, you may have that chart memorized, you can use that, or you can use a calculator, and you could do t is equal to the cosine inverse of √3/2. But this is something that you should know without a calculator, all right? And it's 30 degrees. So if you have that table memorized, the cosine of 30 is √3/2. So therefore, t has to equal 30 degrees. Now, it does say between 0 and 2 pi, which means that we should really answer in radians. So I'm going to write that in radians, which is pi/6. So we get that's pi/6. So that's one of our solutions. All right. Now there's another solution, which is in quadrant 4, where the reference angle is also pi/6, but it has to be between 0 and 2 pi, and in quadrant 4, so it's going to be 330 degrees, or 2 pi minus pi/6, which would be 11 pi/6. All right, so you got the angle in quadrant 1 and the angle in quadrant 4. Both quadrants where cosine is positive, and both those angles have reference angles of 30 degrees. So those are our two answers. So our two answers are right here, 11 pi/6 and pi/6. Okay, so isolate the trig expression. In this case, we isolated the cosine of t. Then do the inverse. And usually you could do that without a calculator. But you can always check it with a calculator. And then find which quadrants would make sense based on is the ratio positive or negative. And then use the reference angle from this step and the quadrants from this step and put that together. All right, so pi/6 and 11 pi/6. And you always want to answer in radians if it says it like that. T is between 0 and 2 pi. All right, so the next one will also answer in radians. If it said t is in between 0 and 360, then we answer in degrees. For number 3, first thing we're going to do is isolate the trig expression. So in this case, the trig expression is the tangent of theta. So we need to get that alone. So I'm going to do sad mep. I'm going to add and subtract first, then multiply and divide. So if I subtract 2 on both sides, I get 2 tan of theta is equal to -2. Then divide by 2. And I get the tangent of theta is equal to -1. So to do this, you need to know that the tangent of 45 degrees is equal to 1. But since we're looking for the tangent of theta is equal to -1, we're going to have to look in negative tangent quadrants. So tangent is positive in quadrants 1 and 3, but it's negative in quadrants 2 and 4. So we're looking for 45-degree angles in quadrant 2 and quadrant 4. And since it says find theta between 0 and 2 pi, we're looking for those angles in radians. So the first angle would be 135 degrees, which in radians would be 3 pi/4. All right, so that's one of our solutions. That's going to satisfy this, 3 pi/4. Okay, because it's a 45-degree reference angle, because the tangent of 45 equals 1, the absolute value of that, but it's in a negative tan quadrant 2. Our other answer is going to be a 45-degree angle in quadrant 4, which would be 315, which if we convert that to radians, would be 7 pi over 4. So that's our other answer, 7 pi over 4. And we found all the angles between 0 and 2 pi. So that's it. So that's our two answers right here. All right, so we did one sine example, one cosine example, one tangent example. And for all of them, we followed the same steps. We isolated either the sine of t, the cosine of theta, the tangent of theta. Then we did inverse operations to figure out what our reference angle was. Then we looked at the quadrants based on and looked at the sine of our ratio, right? So in this case, our ratio was negative, and tangent is negative in quadrants 2 and 4. So we knew we had to find angles in quadrants 2 and 4 that had our 45-degree reference angle. And then if it says answer in radians, just answer in radians. All right. Now let's look at a secant one. So for secant, all we're going to do is approach this the same way by isolating the trig expression. So like getting the secant of theta alone. And then once we have that isolated, then we could just flip it and turn it into cosine. So let me show you what I mean. All right, the first thing I would do here is subtract 4 on both sides to help us get secant alone. So I get negative root 3 times secant of theta is equal to 2. All right, then I'm going to divide both sides by root 3. So we get the secant of theta is equal to 2 divided by root 3. Now we could rationalize this and get rid of the radical in the denominator, but I wouldn't do that yet because we don't have to. I would only simplify things when it's in our final answer. Other than that, you're just kind of, you might be wasting time. So the reason why you're wasting time here is because when you convert this to cosine, all right, so secant is equal to 1 over cosine. So if we flip it, then if secant, we change it to cosine, that means we have to flip 2 over negative root 3, which would be negative root 3 over 2. All right, so same thing would happen if I had like the cosecant of theta is equal to 2. All right, that means the sine of theta is equal to 1/2 because cosecant and sine are reciprocals. So if you go from cosecant to sine, you can just flip 2 to 1/2 and you're good. So now we have to figure out what angles satisfy this equation here. So you should know that the cosine of 30 is equal to root 3 over 2. All right, if you did on your calculator, the cosine inverse of root 3 over 2, you would get 30. And you always want to do the absolute value of the ratio when you're doing the inverse, because then you'll always get the reference angle. Now, if you don't, you could get away with it, but it's so much easier if you always do the inverse of the absolute value of this ratio. So if it's negative root 3 over 2, you do it of positive root 3 over 2. All right, and you get 30. And again, this is something that you should know without a calculator. And if you don't, I highly suggest you memorize this table. If you remember, go sine, cosine, tangent, 0, 30, 45, 60, 90. This goes 0, 1/2, root 2 over 2, root 3 over 2, 1. This goes 1, root 3 over 2, root 2 over 2, 1/2, 0. This goes 0, root 3 over 3, 1, root 3, undefined. All right, I probably should have done this at the beginning of the video, but if you don't have this memorized yet, you should, because that's how I'm able to do all these so quickly. All right, that's how I'm able to figure out the cosine of what equals root 3 over 2. Well, I know the cosine of 30 is equal to root 3 over 2, so now I just got to figure out which quadrants is cosine negative in, and then find angles with 30-degree reference angles in those quadrants. All right, so memorize that table, and if you don't have it memorized, I would write it down, and I would keep it near me anytime you did these problems, and make your life a lot easier. All right, and it's also like the same thing as a unit circle. So it's just another version of the table. Okay, so now I'm looking for 30-degree angles in quadrants 2 and 3, because that's where cosine is negative. All right, A, S, T, C. So cosine is positive here and here. All right, it's negative here and here. So I need to find a 30-degree reference angle in quadrant 2 to solve this right here. So that would be 150 degrees. So that's one of our answers, 150. But it wants the answer in radians, so we'll answer in radians, 5 pi over 6. So there's one of our answers. The other one would be a 30-degree reference angle in quadrant 3. So that would be 180 plus 30. So that'd be 210, which in radians would be 7 pi over 6. That's it. Those are our two answers, 5 pi over 6 and 7 pi over 6. All right, so this is great review for all the stuff that we've done so far in Trig, which is why we kind of do it now. It reviews algebra stuff, and then it also reviews, trig inverses, reciprocal, identities, and all that good stuff. All right. Now let's try this one where we have an expression inside our parentheses. So we have the sine of a plus pi over 2 is equal to negative root 2 over 2. So first thing I would do is I would kind of do some sort of substitution here where we ignore what's inside the parentheses and we just let it equal one value for now. So essentially we're solving the sine of x equals negative root 2 over 2. All right, well, I know that the sine of 45 is equal to root 2 over 2. So that means that x has to be in quadrants where sine is negative. So A, S, T, C. All right, so sine is positive here and here, but it's negative in quadrants 3 and 4. So if we take a 45-degree reference angle in quadrant 3, that's 225 degrees, right? So x could be 225. All right, and we know that the sine of 225, so if a plus pi over 12 equals 225, it's going to equal negative root 2 over 2. So that's one value of x. All right, another one would be a 45-degree reference angle in quadrant 4, another quadrant where sine is positive. All right, so that'd be 315. Okay, so those are in degrees, and we're answering in radians. So if we convert those to radians, 225 in radians would be 5 pi over 4, and 315 in radians would be 7 pi over 4. Okay, so that means that we want to take the sine of 5 pi over 4 to get negative root 2 over 2, and also we want to take the sine of 7 pi over 4 because we know that's also equal to negative root 2 over 2. So, in other words, we want a plus, we want a plus pi over 12, we want that to equal 5 pi over 4. So when you have like a weird expression inside the parentheses, ignore it at first, figure out like what angle would you plug into the parentheses to get this value. So that's why I called it x at first. So that's why I'm sort of doing substitution. I said let x be a plus pi over 12, and then sub it back in and then solve for a. So now I'm just going to subtract pi over 12 on both sides. And let's see, I could get a common denominator here. So this becomes 15 pi over 12. So I get 14 pi over 12. That would be one of my answers. All right. And then do the same thing for the other angle, 7 pi over 4. So I want a plus pi over 12 to equal 7 pi over 4. So I got to subtract pi over 12 on both sides. All right, so this becomes, if I get a common denominator, that becomes 21 pi over 12 minus pi over 12 would be 20 pi over 12, which is our other answer. And then I didn't simplify those, so you should do that. All right, so this becomes 10 pi over 6 or 5 pi over 3. Wait, let's see, 10 pi over 6. Yeah, 5 pi over 3. Nice. And then this becomes 7 pi over 6 if you simplify it. So those are our two answers. All right, so just like the other ones, I just kind of ignored the a plus pi over 12 at first, and then at the end substituted back in and solved for a. All right, let's do one more example. I'll let you try this on your own. I'm just kind of showing you every little thing that you might get here. Oh, there's a bunch more. Geez, I don't have to do all of them. They're kind of similar. Let's see. So this one is interesting because look what happens here. So if we were doing number 6, right, just like the rest of them, we would get the cosine of theta alone first. Now, when we do that, by subtracting 2 on both sides to start, we get 4 times the cosine of theta is 0, which means the cosine of theta is equal to 0. So this is a simplified version of the equation that we were given. All right, so now we got to find all angles between 0 and 2 pi that satisfy that. So if we use our table, we know that the cosine of 90 is equal to 0. Or if you use a unit circle, you know that a 90-degree angle crosses unit circle at the point 0, 1. And cosine is always the x-coordinate of where angles cross the unit circle of those points. All right, so one of our answers could be 90 degrees or pi over 2. But you can also have an angle that has a 90-degree reference angle in quadrants 3 and 4. So you got pi over 2, but also 3 pi over 2. Both of these angles have 90-degree reference angles. So another answer would be 3 pi over 2. And again, if you're using the unit circle, all right, this is the point 1, 0. This is the point 0, 1. This is negative 1, 0. This is 0, negative 1. If you remember, on the unit circle, cosine is the x-coordinate, sine is the y-coordinate. So the cosine of 90 is equal to 0, and the cosine of 270 is also equal to 0. So you can also use the unit circle. If you did this on a calculator, it did like the cosine inverse of 0, it would only give you 90. Because remember, cosine inverse is only going to give you angles between quadrants 1 and 2. That was something we learned back when we did inverses. All right, so this one was interesting because we had 0 here, but still we get two answers, pi over 2 and 3 pi over 2. As well finish these at this point. I think these are quicker because I see what happens here. Now, if we were doing 2 sine of x minus 3 equals 0, right, what we would try to do first is to isolate the sine of x. Divide both sides by 2. Now we get the sine of x is equal to 3 over 2. Now, if we were in class and I could look you all in the eye, I would ask you to tell me what happens here. But I learned from virtual teaching, if I ask a question, no one's going to answer it. So I'm just going to answer it myself. But feel free to jump in. If we have the sine of x is equal to a number, 3 over 2, if we try to type that in a calculator, it's going to give us a funky answer. If we think to y, that's going to happen. It would say something like a domain error. All right. If you think about y equals the sine of x, it can only, if you think of the graph of y equals the sine of x, it's only going to equal numbers between 1 and negative 1. So at most, sine could be 1. At least, sine could be negative 1. So if we have it set equal to 3 over 2, all right, that would be like somewhere up here, 1.5, that's 3 over 2. These will never intersect, all right? So it's important to know that the range of sine of an angle is always going to be between 1 and negative 1. Cosine of x, it's only going to equal numbers between 1 and negative 1. All right, tangent, that could actually be any real number. So like that has a range of all real numbers. So tangent could equal like 2, 3, 4, 100, because that's the ratio of y over x. But cosine and sine equals like y over r and x over r, or opposite over hypotenuse and adjacent over hypotenuse. But the opposite leg can never be bigger than the hypotenuse, and the adjacent leg can never be bigger than the hypotenuse. So that means that this ratio can never equal anything bigger than 1 or less than -1. So if you ever get something like this, where it's the sine of x equals something greater than 1 or less than -1, there's just no solution. All right? And if you did this on the calculator at this point, the sine inverse of 3 over 2, it would tell you that there's no solution because it's not in the range. Okay? So be mindful of that. If you get sine of x or cosine of x equals something bigger than 1 or less than -1, it doesn't work. All right, and then we might as well finish this off here. It's the last one. So we're going to get sine alone. So I'm going to first subtract 3 sine of theta on both sides. So I get -2 is equal to 4 sine of theta minus 1. All right, then I can add 1 to both sides. I get -1 is equal to 4 sine of theta. And I could divide by 4. And I get the sine of theta is equal to -1/4. All right, so we're going to subtract 3, just double check on my work, add 1, divide by 4. Okay, now this is something, so the other problems we didn't need a calculator to do. But for this one, we need a calculator to do this because -1/4 is not one of those ratios that is in that chart that you have memorized, right? It's like 1/2, √2 over 2, √3 over 2, 0, 1, okay, not -1/4. So that means we need to use a calculator to figure out what angle do you take the sine of to get -1/4. So we're going to do the sine inverse of -1/4 on the calculator. And actually, we're going to do the sine inverse of +1/4 to get the reference angle. And then once we have the reference angle, we can figure out where sine is negative and go from there. All right, so now you have to turn on your calculators. Oops, I tried to let someone back in. So turn on your calculators. Oh, here we go. Mine's going to turn on in a second. And we have to do sine inverse. Sorry, I had this open earlier. Take a second for mine to load. It's not loading. Let's see. Give me a second. There we go. If you're watching the video, I'd fast forward at this point. And then once I have this open, I'll show you how you could check your work with a graphing calculator, which you could do with any type of calculator. It doesn't have to be a CAS. All right, so we're going to open up a new calculator. Oh my gosh, come on. All right, so open up a new calculator, not a graph yet. All right, and remember, just to refresh our memory, we had it down to the sine of x is equal to -1/4. All right, you don't have to write that. I'm just putting in what we're trying to figure out here. So we're going to do the sine inverse of +1/4. Because before I hit enter, I'm going to make sure I'm in degrees. All right, so I put the cursor right here and I see I'm in degrees. So I see that the sine of 1/4, the sine inverse of 1/4 is 14.4, which means that the sine of 14.4775 degrees is equal to 1/4. All right, now I was trying to figure out what angle do we take the sine of between 0 and 360 to get negative 1/4. So I need to find angles in quadrants 3 and 4 that have reference angles of 14.4 degrees. So for quadrant 3, I would do 180 plus the reference angle, 194.78. And if I was doing quadrant 4, I would do 360 minus the reference angle. And those are our two answers. Now, if I plug it back in, if I do the sine of that, I get negative 1/4. If I do the sine of that, I get negative 1/4. And it all came from finding the reference angle by doing the sine inverse of the positive ratio and applying that to the quadrants. So these are our two answers in degrees between 0 and 360, 194.478 and 345.522. Now, when you do the homework, which you're going to start right now, I want you to check your work by graphing. All right, I don't want you to do it this way. I want you to check your work this way, but you could solve any equation by graphing both sides. So if I graph the left side here, all right, 3 times the sine of, I'm going to use x, not theta, minus 2, all right, and then I'm also going to graph 7 times the sine of x minus 1, right? And I'm going to make sure that I'm in degrees, so I'm in radians. So I got to change the angle to, all right, this is weird because I'm going to change the graphing angle. So menu, settings. Okay, so you got to go menu, settings, and make sure that the graphing angle is in degrees. That's different from this little gear up here. So you can do this on Desmos, probably a lot easier. All right, then remember, x is degrees, and we only want answers between 0 and 360. So now I could change my viewing window to give me only angles between 0 and 360. So that I could just see where these sides intersect on that interval, right? So this shows me all the values of x between 0 and 360. Now I got to find where these two graphs intersect. If I go menu, analyze graph intersection, I see this one intersects at 194, which was one of our answers. It's just rounded. And then the other intersection is going to be at 346, which is rounded, but the other answer that we got here. All right, so you can always check your work by graphing both sides and seeing where they intersect. And that's it. So if you, in this last one, we got the sine of theta or cosine theta equal the ratio that we didn't have memorized, then you have to use the calculator. For the first 6, you got ratios like 1/2, √3/2, √2/2. So you didn't have to use a calculator. But you can always use a calculator to check your work. All right. So if you have any other questions, stick around and ask. I'm going to end this video now. See if it was recording. Oh wow, it actually recorded. Nice.